3, 2, 1, ready, go. All right, guys, in this video, we're going to show you some techniques on how to solve exponential equations, and we do that using a very important tool. And we're going to tell you the name of this tool here in a moment, and that's really what this lesson about is, what this tool is and the properties of this particular tool. But before we get started, you see this is a simple equation that I posted for you because I want you to think about the process that, suppose if you couldn't do that equation in your head, what would be the algebraic step that you would use? You see 5 plus x equals 9. What algebraic step would you use to solve that problem? Well, that's right. You would subtract 5 from both sides. And of course, this is an inverse operation, and that's not a hard equation. You probably knew the answer was x equals 4, but I wanted you to be thinking about the fact that it was an inverse operation. Now, what if we trick it up a little bit, and then we go to an equation that looks like this? The square root of x equals 4. Notice that the variable now is under the square root. How would you solve that? What's the inverse operation of the square root? That's right. The inverse operation is squaring. So I would square both sides, and I would square both sides. That would cancel out the square root, and I would get x equals 16 as my solution. So right now we're talking about inverse operations, operations that undo one another. And finally, for equation 3, if I got x squared is equal to 9, how would I solve that equation? Well, I would do that by taking the square root of both sides. And I end up getting x equals 3. Now, my next question for you is, well, what do you do for an equation where the x, or the variable, doesn't have to be x, it can be any letter you want it to be, but what do you do when you see that variable is in the power instead of not in the power? As an example, what if it looks like this? Now, I know that you could probably maybe even solve that in your head, but the purpose of this lesson is to get you used to doing a problem like this when you can't completely solve it in your head. What would we need to do? Well, I do know that I cannot solve this equation by multiplying or dividing the 25 or the 5 or whatever. I can't solve it by subtracting or adding. None of these are inverse operations. I can't even solve it by squaring or square rooting, even though it looks like that's something I should be able to do. I can't even solve it by cubing it or cube rooting it. So the big question is, what are we going to do with this right here? How would we solve this equation if the numbers were presented in such a way that you couldn't do it in your head? Do you know what that is? Well, guess what, everybody? Welcome to the amazing field of mathematics. Welcome to logarithms, all right? And the reason why I'm saying welcome to logarithms is the inverse operation of an exponent, meaning a logarithm can undo an exponent can undo a logarithm. And so I've given you this equation basically that you're familiar with, okay? It's the base of a number raised to the power of the exponent gives you an answer. That's an exponential equation. And what I want you to know is that logarithms are the inverse of exponential. So what that looks like this, if you have an operation of addition, of course, you know the inverse operation for that is subtraction. If you have the operation of squaring something, the inverse of that is square rooting. Well, for exponentials, the inverse operation is logarithms. And of course, you can run that vice versa. Okay, and we're going to talk about how we solve, coming up on the next slide or two, we're going to talk about how we solve an exponential equation. But let's talk a little bit about what the logarithms do. So logarithms switch the domain and range of exponentials. So if I have an exponential equation that looks like this, the base to the power of the exponent equals the answer. What that looks like is your domain is your exponent. It's whatever variables up there. Your range is whatever answer you end up getting. Well, in a logarithmic equation, it looks like this. It says log to the base of answer equals exponent. And what that means is your domain and your range have simply switched places. So you're going to see some logarithms in action. But before we start those logarithms in action, I want you to think about a couple of things. I want you to think about a function and its inverse. Okay. So if I give you this right here, I say f composed of f inverse of x. Remember, way back in the October, November time, we figured out that that was equal to x because a function and its inverse undo each other. Okay, and if I do the inverse of the function f of x, it undoes each other. Okay, so remember that. All right. Well, the reason why I'm showing you this is if I say b to the power of the log base b of x, right, that log base b of x is in the power. So if you see that in the power, you know that that's just equal to x. And if I say the log base b of b to the x power, that's b to the x is right there. It's still equal to x. So I'm just wanting you to know that logarithms and exponentials undo each other. And of course, if I do the natural exponential and natural log, e to the power of the natural log of x, that natural log of x is in the power, that's just equal to x. You'll see that as like trick questions on your SATs and calculus type problems. Or the natural log of e to the power of x, that's just equal to x. All right, so before we go on any further, I do need you to know that logarithms have some very important properties that you need to really kind of learn what they do. So you might want to hit that link below that's popping up, and I'm using brand new YouTube wizardry to do this. But if you need to see a video about the properties of logs and how those properties works, click that link below. All right, well, we're going to keep on going. Okay, so as we solve this exponential equations, notice that the reason I'm calling it exponential is because x is in the variable 8 to the power of x equals 64. I do realize you could probably do this one in your head, but I'm showing you this one just so that when you can't do it in your head, you know what process to follow. Well, in this case, in order to get the x out of the exponent, I've got to take the log base of 8 to both sides. And so what that looks like is that right there. I took the log base 8 of 8 to the power of x equals the log base 8 of 64. And so to solve that equation, what happens is the log base 8 of 8 to the power of x, those end up canceling each other out. And so that my answer is actually x equals the log base 8 of 64. Now we can actually simplify that, and you know we can simplify that probably because you know what number is supposed to go up there where the x is. But the question we use to solve this problem is, I ask myself this. I say, what power of 8 is equal to 64? And I do apologize that you can't see the word what, but that's what I'm asking myself. What power of 8 is equal to 64? Well, when I take a look at that, the power of 2 is equal to 64 if my base is 8, because 8 to the second power equals 64. And so what that means is my solution is x equals 2. Now, I'm going to leave a example, a short, quick little example, and see if you can solve it.